Hello all, today we will be discussing about what is Jetstreams and its phenomena and various features. So before moving into Jetstream, let me introduce myself to you. My name is Krish Nayak. I'm a software developer by profession and I'm an UPSC aspirant too. So today we will be discussing each and everything about Jetstreams in completely depth. So Jetstreams, we are going to discuss various things like its features, how does it get generated, where does it get generated, what is the climate, what is the impact or what is the effect of jet streams on the climate change through which it flows, and each and everything. So let us go ahead. So here is a small overview of today's session. We are going to discuss what is jet stream and what are its properties. We'll also be discussing about where does the jet stream originate. Now, the third point that we are going to discuss is basically about planetary winds. So we need to know about the planetary winds before understanding the jet stream too. So I've given a small point over here where we'll be discussing about Ferrel, Hadley, and polar cells. The fourth point is how does the jet stream originate? And the fifth point is what are the jet stream effects on the climate change, through which region it is flowing, what are the basic climate changes that usually happens. So initially, let us move ahead. We'll see what are the jet streams. So usually you can define a jet stream as a narrow belt of winds that actually flow in the upper troposphere. This kind of winds are usually around 1000 to 3000 miles long. They are around 1 to 3 miles thick and they flow at a very faster speed, that is around 200 to 400 kilometers per hour. This jet streams basically flow from west to east direction. Hence, they are called westerlies. And one more property that we need to take a note of, jet stream usually flows in a meandering manner. It forms a wave-like structure when it is rotating around the Earth. So this wave-like structure is basically due to various high pressure region and the low pressure region that are distributed when it is flowing around the Earth. Now, on the right hand side, you see the smaller image. There are basically two kinds of jet streams. One is a subtropical jet stream, the other is the polar jet stream. So we will be discussing how this subtropical jet stream gets generated. Apart from this, how this polar jet stream gets generated. So let us move ahead with the next. Now the next question is, where does the jet stream originate? Now as you know that our atmosphere is divided into various layers. We have troposphere, stratosphere, mesosphere, thermosphere, and the outer one is called as exosphere. Let us give me a small brief about these layers. So in the troposphere, usually we have the atmosphere that are actually fit for human beings to live. Then after the troposphere, there is a layer called as tropopause, which is actually the layer that divides the stratosphere and the troposphere. In the stratosphere usually have a layer called as ozone layer. The ozone layer plays a very important role. It actually protects the harmful UV rays to enter the earth from the sun. And the next layer is basically the mesosphere, and the other layer on top of that is called as thermosphere. In the thermosphere, we also have a layer called as ionosphere. Ionosphere is having a lot of charged particles. The charged particles helps in propagating the radio waves in different location of the earth. And the most outermost layer is basically called as exosphere. Now we should know, where does the jet stream originate? Jet stream usually originates in the troposphere region. Now we will be discussing about more into it, like how does it generate and all the other kind of features. So now before moving into jet stream, we need to know what is Ferrel, Hadley, and polar cells. Ferrel, Hadley, and polar cells also leads to the generation of planetary winds. So as you know, in the equator, right, which is shown as an intertropical convergence zone over here, in the equator we get intense amount of heat because the sunlight are actually falling on the equator directly, due to which what happens, air gets warmer and it rises up in this direction. Once it rises up, at a particular point of time it starts moving towards the high pressure region, because this is the low pressure. On the top it becomes high pressure, and once it cools down it descends, and it moves towards the tropical or the polar side, you can say. This is the polar side. So I'm just giving you a direction, it moves towards the polar side. Now what happens when it moves towards the polar side, it starts descending. And once it descends towards this 30-degree north altitude, sorry, latitude. Once it gets descends, after it reaches this particular 30-degree north, this is basically the high pressure area. Now, as we know, since due to intense heat, the low pressure area gets formed over here. Now, from this high pressure region, the air starts moving towards the low pressure region, that is in the intertropical convergence zone. So once it is moving, due to the Coriolis force created by the rotation of the Earth, the the direction of the air basically moves towards its right due to the Coriolis force. So this we call it as a planetary winds. This planetary winds, they start reflecting towards the right at an angle of 45 degree. Once it moves towards the intertropical zones, and again the same cycle starts. It comes over here, again it gets heated, it goes up, again it descends down in 30-degree north, and it again forms at the planetary winds. So this is basically a Hadley cell. This was actually mentioned by George Hadley, so the name is called as Hadley cell. Now, this is one of the planetary winds that we have. Similarly situation we have in the 60-degree north and 60-degree south. In the 60-degree north, due to the high pressure created in the polar front, the air rises up, it goes to the polar side, again it descends down, and again it forms this particular cycle. Similarly, it happens with this particular cell. So, due to this all, there are three kinds of cells that are created. One is Hadley cell, one is Ferrel cell, and one is polar cell. Now, we know that due to these cells, planetary winds gets formed. But where does jet stream gets formed? We still don't know. Where does it get formed? So let me again tell you once again. So as we know in the equator, we have intense amount of sunlight that is falling. So once it goes up, it descends, it moves towards the polar side. Now there are some of the warm winds basically. It goes to the upper troposphere. Once it goes to the upper troposphere and starts moving toward the polar side, it does not get descended at this particular 30 degree because it still has some of the warmth in it where it does not descend at this particular degree, basically the 30-degree north. So what happens once it is moving towards the polar, there, since it is in the upper troposphere also, the Coriolis force, since the distance from the equator of that particular air is quite high, the Coriolis force also acts upon it in a more speedy way. So the Coriolis force impacts more when compared to this planetary events. So hence, if I show you in my next diagram, it'll give you a proper idea. So we have the heated air that is rising up. Once it rises up and reaches the upper troposphere, it moves towards the North Pole. Since high pressure is created here, and in the North Pole, the low pressure is created because there is not enough of sunlight that is actually reaching the Northern Pole or the Southern Pole. So once it's moved toward the North Pole and the South Pole, as we know that in the upper troposphere, right, there is less density of air. So the winds move towards the North Pole and South Pole in the faster speed. So once it goes, the Coriolis force also impacts those winds in a faster way. So here is the right side diagram. Now the from the equator, the upper tropospheric winds are actually moving towards the poles. Now once it is moving, the Coriolis force makes this wind deflects towards its right at an angle of 90 degree. As we saw that in the planetary winds, the direction was just around 45 degree. It was deflecting around 45 degree. But why this is getting deflecting at 90 degree? Because these winds are still at a higher side. So the Coriolis force impacts more and it deflects that particular wind to a 90 degree to the right. Similarly, in the southern side, it deflects this wind at an angle of 90 degrees to its left in terms of the direction of wind. In the southern hemisphere, it is towards the left in terms of the direction of winds, and the northern hemisphere, it is towards the right. It is towards the right in terms of the direction of the winds. So this leads to the formation of jet streams, which are basically called as westerlies. This will be moving from west to east and it will continuously moving around the earth. Now, due to this, what happens? This direction kind of winds gets created, and these are basically the jet streams, which will be flowing in this manner, basically in a curvy manner. They'll be meandering from one place to the other. And similarly, two types of jet streams get created. One is the subtropical jet stream and the polar jet stream. Similar in the south, which is subtropical jet stream and the polar jet stream. This is what is the this is how actually the jet stream is getting created. And this gives you an idea like now this meandering thing also, right? We need to also discuss about the meandering thing. Why it gets meandered. As we know that usually when the winds flow in a meandering manner, it usually forms trough and ridges. In the trough, basically, it creates an high pressure region, and the ridges it creates a low pressure region. Because of that, due to the difference in the pressures, it creates this kind of meandering way, basically. Okay, let us see the next thing. Some of the features that actually are also involving in the direction of the jet stream that it follows. It alters the direction, basically the amount of different kind of air masses. Now suppose this colder air mass and warmer air mass is present. Now what happens during the summers? During the summers, this colder air mass due to excessive heating in the northern hemisphere, this may move little bit up. Similarly, the warmer air mass will move up and the direction of jet stream will also get altered and it will instead it will move it is moving from here, it will move from here. Similarly, in the winter season, what happens? The southern hemisphere receives more amount of sunlight, so the warmer air mass moves down. Similarly, the colder air mass moves down, and due to this, again the jet stream will come to in this path, how it is shown over here. And due to this, there may be various impacts on the climate change because this colder air mass will lead to freezing of temperature in this particular region through which the jet stream is flowing. So let us see the other slides. Here you'll get the clear idea during the winter season what happens. Now in the winter season, as we know that the sunlight is the southern hemisphere receives more amount of sunlight. So this colder air mass tends to move towards the southern direction. Now due to which a very low pressure is actually created and this leads to the freezing of temperature because of the colder air mass and the jet stream that is flowing through it. Some other effects of jet streams. It is also beneficial. Jet streams is sometimes beneficial. The most beneficial people on jet stream are the airline industries. Various kind of pilots, they are actually trained to ride the flights, basically to ride the flights on this jet streams. Now you know that this jet stream speed is around 1000 to 3000 kilometers per hour, right? Sorry, 200 to 400 kilometers per hour. Now, if somebody rides a plane in this jet stream, then obviously the the plane will actually save its fuel, right? The pilot will be able to save the fuel of the plane and it will move towards a move in a faster way towards the destination. So that is how actually it is beneficial for the airlines industries. Many pilots are getting trained into it. The best example I can show you over here is in this way. Now suppose this jet stream is flowing in this direction and suppose the plane comes in this direction and moves along the jet stream, it does not have to spend much fuel. Instead, the jet stream provides the strength to move towards its destination. So these are the basic things that we discussed. And I hope we have covered each and everything over here. First of all, just let me again take a overview. We discussed about what are jet streams and its properties. We discussed where does jet stream originate. We discussed about the planetary winds. We discussed about various cells called as Fair, Hadley, and polar cells. Apart from that, we also discussed about upper tropospheric winds and jet streams. As we said that as the upper tropospheric winds move towards the pole due to the Coriolis pole, it gets moved towards the right at an angle of 90 degree. Similar in the southern pole, it gets moved towards the left at an angle of 90 degree in terms of the direction of winds. Now, this is how the jet stream is actually formed. We have two types of jet streams, that is called subtropical jet stream and polar jet stream. This similarly gets formed in the southern direction too, in the 60-degree north, 30-degree south and 60-degree south. And the direction of the jet stream is also altered by the different air mass that it is getting surrounded by. So this is how I gave you an example. In the northern hemisphere, when the summers there is cold air mass will move towards the northern hemisphere, and warmer air mass will move also towards the northern hemisphere. At that time, the jet stream will move somewhere around from here, and it will rotate the earth. Similarly, in the winter season, it will be in opposite direction. And this is one of the effects, and we also discuss about one of the beneficial, which is for the airline industries. So this was all about jet streams. Do let me know from your comments, like how did you like this video, and if you want to discuss any more topics, you can tell me. You can just tell me the topic and I'll make a video on that too. Till then, have a great day